What if I told you that right now, at this very moment, something from another star system is racing through our solar neighborhood at over 130,000 miles per hour? What if this visitor, larger than Manhattan itself, has scientists so divided that some are calling it the most important discovery in human history, while others dismiss it as just another space rock? And what if the timing of its arrival, its composition, and its behavior are so unusual that even NASA can't fully explain what we're looking at? Welcome back to She Speaks Anyways, where we dive deep into the mysteries that challenge everything we think we know. Today, we're talking about Comet 3I Atlas, an interstellar object that has sparked one of the most intense scientific debates of our generation. Is it an alien mothership deploying surveillance probes? Or is it simply the oldest comet ever recorded, carrying secrets from the birth of distant star systems? By the end of this video, you'll understand why Harvard's most controversial astrophysicist staked his reputation on the possibility of extraterrestrial technology, why NASA activated its planetary defense protocols, and why the date, October 29th, 2025, might go down as one of the most significant moments in human history. So buckle up, because this story is about to take us on a journey beyond the boundaries of our solar system and into the realm of the unexplained. Part 1. The discovery that changed everything. Let me take you back to July 1st, 2025. It was just another night at the Atlas Telescope facility in Rio Hurtado, Chile. ATLAS stands for Asteroid Terrestrial Impact Last Alert System, and it's designed to do exactly what it sounds like: scan the skies for objects that might pose a threat to Earth. The system has been scanning for years, cataloging asteroids, comets, and space debris with robotic precision. But on this night, something appeared on the monitors that made astronomers across the world stop what they were doing. The object was initially designated A11C-IL3Z, and within hours of its detection, scientists realized they were looking at something extraordinary. This wasn't another asteroid from the Kuiper Belt. This wasn't a comet from the Oort cloud. The mathematical trajectory was unmistakable. This object was moving on a hyperbolic orbit, traveling at speeds that exceeded our sun's escape velocity. It was coming from interstellar space. Think about what that means for a moment. In the entire history of humanity, with all our telescopes and technology, we've only confirmed 3 interstellar objects passing through our solar system. The first was 1I Oumuamua in 2017, that cigar-shaped mystery that sparked its own alien speculation. The second was 2I Borisov in 2019, which astronomers agreed was likely a natural comet. And now 3I Atlas, the third confirmed visitor from beyond. Within 24 hours of the initial detection, the Minor Planet Center published preliminary data and called for immediate follow-up observations. Telescopes around the world swung into action. What they found was both fascinating and unsettling. Pre-discovery observations were quickly identified, with images going back to June 14th, 2025. Amateur astronomer Sam Dean noted that the comet had been passing in front of the galactic center's dense star fields, which is why it hadn't been spotted earlier. It was hiding in plain sight, camouflaged against billions of distant stars. By July 2nd, observatories in Chile, Arizona, and Hawaii confirmed that this object had a diffuse appearance with a coma, the cloud of gas and dust that forms around active comets as they heat up. They designated it C-225N1, giving it official comet status. But this was no ordinary comet. The Hubble Space Telescope turned its powerful eye toward 3I Atlas on July 21st, capturing images that revealed something remarkable. The comet had a teardrop-shaped cocoon of dust streaming away from its nucleus. But here's where things get interesting. When NASA's SETI mission observed it in mid-August, they discovered that the comet's coma extended over 348,000 kilometers in radius when viewed in near-infrared light. That's almost the distance from Earth to the Moon. And it was growing. Initial estimates suggested the nucleus, the solid core of the comet, could be anywhere from 440 meters to 5.6 kilometers in diameter. That's roughly the size of Manhattan. But mass estimates revealed something even more staggering. This object weighed at least 83 billion tons, making it between 1,000 to 1,000,000 times more massive than the previous interstellar visitors. To put that in perspective, our most powerful rocket, SpaceX's Starship, is 100 times smaller than this cosmic visitor. The scientific community was electrified. This was the opportunity of a lifetime. Unlike Oumuamua, which was discovered as it was already leaving our solar system, 3A Atlas was detected on its way in. Astronomers would have months to study it, to photograph it, to analyze its composition, and to track its behavior as it approached the Sun. The James Webb Space Telescope, Hubble, the Gemini Observatory, and dozens of other facilities began a coordinated observation campaign. But then something happened that turned excitement into controversy. A single scientist, known for his unconventional theories and his relentless pursuit of evidence for extraterrestrial intelligence, stood up and said what many in the scientific community considered unthinkable. He suggested that 3I Atlas might not be natural at all. He proposed that humanity might be witnessing the arrival of an alien mothership. Part 2, meet Avi Loeb, the scientist who dared to question. To understand the controversy around 3I Atlas, you need to understand the man at the center of it, Professor Avi Loeb. Loeb is no fringe conspiracy theorist working out of his basement. He's a Harvard professor, the former chair of Harvard's Astronomy department, and the founding director of Harvard's Black Hole Initiative. He's published over 1,000 scientific papers, mentored dozens of PhD students, and received numerous awards for his contributions to astrophysics. But Avi Loeb is also controversial. He's the scientist who, back in 2017, suggested that Oumuamua might have been a piece of alien technology, specifically a light sail pushed by radiation pressure. The scientific community largely rejected this hypothesis, preferring natural explanations. But Loeb didn't back down. He wrote a best-selling book about it, founded the Galileo Project to search for evidence of extraterrestrial technology, and continued to push the boundaries of what mainstream astronomy considers acceptable speculation. When 3I Atlas was discovered, Loeb immediately began studying the data, and what he saw troubled him. In a series of blog posts, scientific papers, and media interviews, he outlined what he called the anomalies of 3I Atlas. 9 specific characteristics that, in his view, didn't quite add up to a simple comet of natural origin. Let me walk you through Loeb's arguments, because whether you agree with him or not, they're based on real observational data that any scientist can verify. First, there's the trajectory. 3I Atlas's orbital path falls within just 5 degrees of the ecliptic plane, which is the flat disk in which Earth and 3 other planets orbit the Sun. Loeb's calculations suggested there was only a 0.2% chance that this alignment happened by pure coincidence. If you were designing a spacecraft to study multiple planets in our solar system, you'd want to align with the ecliptic to maximize your gravitational assists and minimize fuel consumption. It's basic astronautics. Second, the timing. 3I Atlas was set to reach its perihelion, its closest approach to the Sun, on October 29, 2025. At that exact moment, the comet would be on the opposite side of the Sun from Earth's perspective. We would be unable to observe it directly. This is called solar conjunction. Loeb pointed out that the probability of this happening by chance was only about 0.5%. Was it a coincidence? Or was it, as he provocatively suggested, orbital design? Third, the close planetary encounters. On October 2nd, 3I Atlas passed within 30 million kilometers of Mars. It would also make relatively close passes by Venus and Jupiter. If you were an advanced civilization sending a probe to study our solar system, these would be exactly the trajectories you'd want. Multiple planetary flybys using gravitational assists. Fourth, the composition. When the James Webb Space Telescope analyzed the comet's coma, it found something unusual. The gas coming off 3I Atlas was 7% carbon dioxide, 9% carbon monoxide, and only 4% water. Most comets in our solar system are a predominantly water ice. This carbon dioxide-rich composition suggested that 3I Atlas formed in an extremely cold environment, far from any star. But it gets stranger. Spectroscopic analysis revealed an extreme abundance of nickel relative to iron in the gas plume. This ratio was so unusual that an international team of astronomers wrote in their paper, "The presence of nickel and iron atoms in cometary coma is extremely puzzling." Loeb went further. He suggested that this nickel abundance could indicate industrially produced nickel alloys. Fifth, the anti-tail. As 3I Atlas approached the Sun, astronomers observed something they'd never seen before in a solar system comet. A second tail that appeared to point toward the Sun, not away from it. While anti-tails are sometimes optical illusions caused by viewing geometry, Loeb argued that 3I Atlas's anti-tail was genuine and unprecedented. He suggested it might be the result of directed mass ejection, perhaps from vents or engines. Sixth, the acceleration. All comets experience non-gravitational acceleration as they heat up and outgas, creating a rocket-like thrust. But 3 Atlas's acceleration profile seemed inconsistent with normal comet physics. Its speed and trajectory adjustments suggested forces beyond simple outgassing. Seventh, the size and mass. At 33 billion tons and potentially 5 kilometers across, 3I Atlas is extraordinarily large for an interstellar object. Loeb questioned whether there was enough material floating in interstellar space for something this massive to form naturally. He called it too large for an interstellar asteroid. Eighth, the activity at distance. NASA's TESS satellite observed 3I Atlas exhibiting cometary activity as early as May 7, 2025, when it was 6 astronomical units from the Sun. That's beyond Jupiter's orbit. Most water ice comets don't activate until they're much closer to the Sun. The fact that Atlas was active so far out suggested volatile materials with very low sublimation temperatures or potentially internal heat sources. Ninth, the presence of nickel tetracarbonyl. This is perhaps the most controversial finding. Spectroscopic analysis detected traces of nickel tetracarbonyl, a compound that on Earth has only been produced in laboratories and industrial processes. It's used in nickel plating and refining. Finding it in a comet from interstellar space raised eyebrows across the scientific community. Loeb compiled these observations into what he called the Loeb scale, a ranking system from 0 to 10, where 0 is definitely natural and 10 is definitely technological. He gave 3 eyes Atlasas a ranking of 4, later revised to 6, and stated publicly that he believed there was a 30 to 40% probability that the object does not have a fully natural origin. But Loeb didn't stop at observation. He made a prediction. If 3i Atlas were a spacecraft, it would most likely execute what's called an O-berth maneuver at Perihelion. This is a spacecraft technique where you fire your engines at the point of closest approach to a massive object, in this case, the Sun, to maximize the change in kinetic energy. It's the most fuel-efficient way to alter your trajectory in space. Loeb suggested that if 3i Atlas were a massive mothership, it might not change course itself. Instead, it could release smaller probes, mini spacecraft that would perform reverse O-berth maneuvers to slow down and intercept various planets in the solar system. These probes could be small enough that we wouldn't detect them directly, but their effects on 3i Atlas's trajectory and brightness might be observable. And here's where things got really interesting. Loeb said that if this were going to happen, October 29th, 2025 would be the moment. The comet would be hidden behind the Sun from our perspective, conveniently out of sight. In a somewhat tongue-in-cheek, but also serious interview, Loeb said, "If you want to take a vacation, take it before then, because who knows what will happen." Part 3. The scientific community pushes back. As you might imagine, Loeb's alien mothership hypothesis did not go over well with the majority of the astronomical community. Scientists lined up to dispute his claims, and their criticisms were pointed and specific. NASA's lead scientist for solar system small bodies, Tom Statler, was unequivocal in his assessment. He told reporters, "It looks like a comet. It's a comet." He acknowledged that 3i Atlas had some interesting properties that are a little bit different from our solar system comets, but insisted that everything observed was consistent with natural cometary behavior. The SETI Institute, which is literally dedicated to the search for extraterrestrial intelligence, also disagreed with Loeb. Their scientists stated that the evidence is overwhelmingly pointing to this object being a natural body. This is particularly significant because if anyone would be excited about finding alien technology, it would be SETI. Their rejection of the hypothesis carries weight. Astrophysicist Chris Lintott of the University of Oxford was even more critical. He told reporters that Loeb's arguments rely on weak data and speculative interpretations. Lintott pointed out that Loeb had a pattern of jumping to extraordinary conclusions from limited evidence, and that his previous claims about Oumuamua had not held up under scrutiny. The scientific community offered alternative explanations for each of Loeb's anomalies. The trajectory alignment with the ecliptic, while unusual, it's not impossible. Interstellar objects have to come from some direction, and a small percentage will naturally align with our planetary plane. The timing of perihelion during solar conjunction, again unusual, but not impossible. About 1 in 200 interstellar objects would have this timing by pure chance. The carbon dioxide-rich composition, this actually makes sense for an object from interstellar space. If the 3a Atlas formed in the outer regions of another star system, billions of miles from any heat source, carbon dioxide ice would be more stable than water ice. The James Webb Space Telescope has found carbon dioxide-rich comets in our own solar system's distant regions. The nickel and iron abundance, while unusual, it could indicate that 3i Atlas formed in a protoplanetary disk with different chemical ratios than our own solar system. Not every star system has the same elemental composition. The presence of metals in the coma could result from the sublimation of dust grains that contain these elements. The antitail, many comets have been observed with antitails. And while 3I Atlas's version might be more pronounced, it doesn't require exotic explanations. The geometry of the dust particle orbits, combined with Earth's viewing angle, can create this effect. The acceleration and activity at distance. Carbon dioxide sublimates at much lower temperatures than water ice. If 3I Atlas is primarily CO2, it would naturally start outgassing far from the Sun. And this outgassing would create the observed non-gravitational acceleration. The size and mass? While large for an interstellar object, it's not impossibly large. We've only detected 3 interstellar visitors. Our sample size is tiny. For all we know, large interstellar comets might be more common than small ones. We just notice the big ones more easily. The nickel tetracarbonyl? This is the hardest one to explain naturally, and critics noted that the detection might be uncertain or could result from misidentification of spectral lines. More observations were needed to confirm this finding. Scientists emphasize that extraordinary claims require extraordinary evidence. The alien spacecraft hypothesis is about as extraordinary as it gets. To prove such a claim, you'd need evidence that definitively rules out all natural explanations. And in the view of most astronomers, that evidence simply didn't exist for 3I Atlas. But Snopes, the fact-checking website, had to step in to debunk viral claims on social media that 3I Atlas was very likely alien. The speculation had gotten out of hand, with some online communities treating Loeb's hypothesis as confirmed fact rather than a controversial minority opinion. Neil deGrasse Tyson, perhaps America's most famous science communicator, weighed in on the debate. He acknowledged that the 3 interstellar objects detected so far don't match some of our models for what comets and asteroids should do. But he cautioned against jumping to conclusions. "I'm delighted that they're finally in the catalogue," Tyson said, "because investigating mysteries is what advances science." However, he warned that calling 3I Atlas an alien spaceship as a substitute for the simple statement, "I don't know what it is," was counterproductive to the scientific process. This is a crucial point. Science advances through mystery, through admitting what we don't understand, and then systematically gathering evidence to solve those mysteries. Prematurely labeling something as alien technology can shut down genuine scientific inquiry rather than encouraging it. Yet Loeb had a counter-argument. He insisted that his hypothesis was testable, which is the hallmark of good science. He wasn't saying, "This is definitely an alien spacecraft." He was saying, "Here are the observations that don't quite fit natural models, and here's a hypothesis that could explain them, and here's how we can test it." October 29th would be the test. If 3I Atlas changed its trajectory or exhibited behavior inconsistent with a passive comet, that would be significant evidence. Part 4. The Perihelion Test. October 29th, 2025. As October approached, the astronomical world held its collective breath. This was it. The moment of truth. If Loeb was right, if 3I Atlas was indeed some form of alien technology, perihelion would be when it would act. And conveniently, or suspiciously depending on your perspective, this would happen while the comet was hidden behind the Sun, unobservable from Earth. Loeb laid out his expectations clearly. If 3I Atlas was a natural comet, the intense solar heating at perihelion, about 770 watts per square meter, might cause it to fragment. Many comets break apart when they get too close to the Sun. The resulting fragments would create a much brighter plume of gas and dust, a spectacular fireworks display that astronomers would be able to observe once the comet emerged from solar conjunction. But if this 3 Atlas was technological, it might execute the Oberth maneuver, altering its velocity and trajectory in ways that couldn't be explained by natural forces. It might release smaller probes. It might exhibit excess heat from engines. It might even produce artificial light or radio signals. While Earth-based telescopes couldn't observe the comet during conjunction, space agencies weren't completely blind. ESA's Mars Express and EXO, Mars Trace Gas Orbiter, observed 3I Atlas as it passed near Mars on October 3rd. The European Space Agency's Jupiter Icy Moons Explorer, or JUICE, was positioned to make observations from about 125 million miles away. NASA's Mars Reconnaissance Orbiter, with its powerful high-rise camera, had captured images of 3I Atlas on October 2nd, when the comet was just 30 million kilometers from Mars. Loeb later claimed that this image, which could have provided the highest resolution view of the comet's nucleus, was never publicly released. He raised this issue on Joe Rogan's podcast, asking why NASA hadn't shared what could be the most important image of the object. NASA has not publicly responded to this accusation. October 29th came and went. The comet reached perihelion at precisely 11:47 UTC, exactly as predicted by orbital mechanics. And then we waited. It would take days or even weeks for 3I Atlas to move far enough from the sun's glare for Earth-based telescopes to observe it again. In November, as the comet emerged from conjunction and became visible once more, astronomers around the world turned their instruments toward it. What they found was both anticlimactic and revealing. As Atlas had survived perihelion intact. It hadn't fragmented. Its brightness and activity level had increased, exactly as you'd expect from a comet that had just been heated by close solar passage. But there was no dramatic change in trajectory, no evidence of mini-probes being released, no artificial signals detected. The Allen Telescope Array had collected over 21 terabytes of radio data during 3I Atlas's approach, listening for both natural radio emissions and potential technosignatures. The analysis of this data showed natural emissions consistent with comet outgassing. There were no narrowband signals, no artificial patterns, no hello from the cosmos. Orbital tracking showed that 3I Atlas continued on its predicted gravitational path. Any changes in velocity could be accounted for by outgassing, the natural rocket effect of sublimating ice. The comet was behaving exactly like a comet. According to NASA's tracking, 3I Atlas posed no threat to Earth and would continue on its hyperbolic trajectory out of the solar system. By December 19th, it would make its closest approach to Earth, passing at about 270 million kilometers. That's safe, very safe. And then it would continue its journey back into the depths of interstellar space, never to return. But here's where the story gets a bit murky. Some reports emerged claiming that NASA had activated its planetary defense protocols in response to unusual behavior observed in 3I Atlas. There were claims of erratic changes in speed, brightness, and trajectory. A supposed international task force was investigating whether the anomalies were natural or something more extraordinary. However, these reports appear to be largely sensationalized or misinterpreted. NASA's Planetary Defense Coordination Office does track 3I Atlas, as it tracks all objects that enter the inner solar system. But there's no evidence of any special alert or emergency protocols being activated. The official NASA statements remain consistent. 3I Atlas is a comet. It's behaving like a comet, and it poses no danger. Loeb, for his part, adjusted his assessment but didn't abandon his hypothesis entirely. In blog posts after perihelion, He acknowledged the 3I-Atlas appeared most likely to be a natural comet. But he maintained that the possibility of technological origin, while remote, couldn't be completely ruled out. He emphasized that science should follow evidence, not expectations, and that we should continue monitoring the object for any unusual activity. The Loeb scale ranking, he suggested, might need to be revised downward, but not necessarily to 0. Some of the anomalies remained unexplained. The nickel tetracarbonyl detection, if confirmed, would still be puzzling. The anti-tail was still unusual. And the fact that we simply don't understand everything about interstellar comets means we should remain open-minded. Part 5. What 3I-Atlas really tells us. So, what's the real story of 3I-Atlas? Is it just a comet, or is there something more to this cosmic visitor? The scientific consensus is clear. 3I-Atlas is a natural comet of interstellar origin. It's an ancient relic, possibly billions of years old, formed in the outer reaches of another star system. It's been wandering through the galaxy for perhaps hundreds of millions of years, slowly making its way through the void between stars. And by cosmic chance, its path intersected with our solar system. This in itself is extraordinary. Think about the journey this object has taken. It may have formed around a star when our own solar system was still young. It may have witnessed the birth and death of other stars. It carries within it pristine material from the early days of its home system, material that could teach us about planet formation, stellar evolution, and the chemical diversity of the galaxy. Dr. Davenport and other astronomers noted that 3I-Atlas's trajectory aligns with the thick disk of the Milky Way, a region populated by older stars. This cosmic archaeology, studying where objects come from based on their trajectories, tells us something profound about galactic dynamics and the distribution of matter in our galaxy. The carbon dioxide-rich composition isn't just unusual, it's informative. It tells us that 3I-Atlas likely formed extremely far from its parent star, in temperatures so cold that carbon dioxide, not water, was the dominant ice. This suggests it came from a system with a very extended outer disk, or possibly that it was ejected from its home system early in its history and spent eons in the near absolute zero temperatures of interstellar space. The nickel and iron detected in its coma tell us about the elemental composition of its parent protoplanetary disk. Different star systems have different chemical fingerprints based on the generations of stars that came before them and enriched the interstellar medium with heavy elements. By studying 3I-Atlas, we're essentially sampling another star system without having to travel there. The size of 3I-Atlas is also telling us something important. If interstellar objects this large exist and occasionally pass through our solar system, then interstellar space must be more densely populated with matter than we previously thought. This has implications for models of planet formation, galactic evolution, and even the potential for panspermia, the theory that life could spread between star systems on natural objects like comets. But beyond the specific science of this one object, 3I-Atlas represents a turning point in astronomy. We're entering an era where detecting interstellar visitors will become routine. The Vera C. Rubin Observatory, which serendipitously imaged 3I-Atlas during its science validation phase, is expected to revolutionize this field. Once fully operational, Rubin could detect dozens to hundreds of interstellar objects per decade. Imagine having not just 3 data points, but 300. We could do real statistics. We could compare compositions across multiple objects. We could track trajectories and determine which regions of the galaxy they're coming from. We could potentially even identify specific star systems as sources. Some of these objects might be active comets like 3I Atlas and 2I Borisov. Others might be inert rocks like Oumuamua. And statistically, over time, we might even find one that genuinely shows signs of artificial origin. Not because aliens are likely, but because with a large enough sample size, even unlikely things eventually happen. This brings us back to Avi Loeb and the controversy. Was he wrong about 3I Atlas? Almost certainly. The object behaved exactly as a natural comet would. There's no evidence that it's technological. The alien mothership hypothesis appears to have been, at best, an extreme long shot that didn't pan out. But was he wrong to propose the hypothesis and insist on testing it? That's a more nuanced question. Loeb would argue, and has argued, that science advances by challenging assumptions and taking seriously even unlikely possibilities. The history of science is full of impossible things that turned out to be true. Continental drift was ridiculed for decades before it was accepted. The existence of meteorites was denied by the scientific establishment. The idea that the universe is expanding was considered absurd until observations proved otherwise. Loeb's critics would counter that while it's fine to consider alternative hypotheses, you also need to proportion your confidence to the evidence. When 90% of the data points to explanation A and only 1% could potentially support explanation B, you shouldn't go around saying, explanation B has a 40% probability. That's not good science, that's sensationalism. The truth, as usual, probably lies somewhere in the middle. We need scientists like Loeb who are willing to think outside the box and challenge orthodoxy. But we also need the careful, methodical skepticism of the broader scientific community to keep wild speculation in check. What's undeniable is that Loeb's controversial claims generated massive public interest in 3I Atlas. Millions of people who normally wouldn't care about an interstellar comet became fascinated by it. They learned about orbital mechanics, spectroscopy, and the scientific method. They engaged with the wonder of astronomy. And that has value. Part 6. The bigger picture. Are we alone? Let's zoom out for a moment and consider the bigger questions that 3I Atlas brings to the surface. Why do we care so much about whether this comet is natural or artificial? Why does the possibility of alien technology capture our imagination so powerfully? Because it touches on one of the most profound questions humanity has ever asked. Are we alone in the universe? The universe contains roughly 2 trillion galaxies, each with hundreds of billions of stars. The Milky Way alone has somewhere between 100 and 400 billion stars. We now know, thanks to discoveries from the Hubble Space Telescope and other planet-hunting missions, that planets are common. Most stars have them, and a significant fraction of those planets are in the habitable zone where liquid water could exist. The numbers are staggering. There could be tens of billions of potentially habitable planets in our galaxy alone. And if even a tiny fraction of those planets developed life, and if an even tinier fraction of those developed intelligent, technological life, there should be civilizations out there. So where are they? This is the Fermi paradox, named after physicist Enrico Fermi. If intelligent aliens are common, their technology should be detectable. Their radio signals should fill the cosmos. Their spacecraft should have visited Earth thousands of times over the billions of years of our planet's history. Yet we see nothing. We hear nothing. The universe appears to be silent. This silence is unsettling. It suggests one of several possibilities, none of them comfortable. Maybe intelligent life is incredibly rare, and we're alone or nearly alone in the galaxy. Maybe intelligent civilizations always destroy themselves before they can colonize the stars. Maybe there are aliens out there, but they're deliberately avoiding us. Or maybe, just maybe, they're here and we haven't recognized them yet. This is the context in which Loeb's hypothesis about 3I Atlas exists. He's not just asking if this particular object is a spacecraft, he's asking a deeper question. Given the vastness of the universe and the statistical probability that technological civilizations exist somewhere, shouldn't we be actively looking for their artifacts? Loeb founded the Galileo project with precisely this goal. The project aims to search for technosignatures, signs of alien technology, using rigorous scientific methods. It's looking for anomalous objects in Earth's atmosphere, unusual signatures in space, and anything that doesn't fit natural patterns. Critics say this is a waste of resources, that the probability of finding alien technology is so low that we should focus on more likely scenario. Supporters say that even if the probability is low, the implications of success are so profound that the search is worth it. And here's the thing, we're at a unique moment in human history. For the first time, we have the technology to potentially detect alien civilizations if they exist. Our telescopes can see exoplanets. Our spectroscopes can analyze their atmospheres for biosignatures. Our radio telescopes can listen for artificial signals. Our space probes can visit interstellar objects. If there's ever been a time when we might actually find evidence of extraterrestrial intelligence, it's now. And objects like 3I, Atlas, visitors from other star systems are obvious places to look. Even though 3I Atlas turned out to be a natural comet, the questions it raised are important. How would we recognize alien technology if we saw it? What protocols should we have in place for responding to a genuine discovery? How do we balance the need for scientific rigor with the need for open-minded exploration? Loeb pointed out that humanity has no official plan for what to do if we discover functioning alien devices near Earth. There's no protocol, no international committee, no prepared response. We're dangerously unprepared for what could be one of the most significant events in human history. Whether you agree with his conclusions about 3I Atlas or not, Loeb is right about this. We should be prepared, and we should be looking. What's the final verdict on Comet 3I's Atlas? The evidence overwhelmingly suggests it's a natural comet, an ancient wanderer from another star system, carrying with it secrets about the formation of planets and the chemical diversity of the galaxy. It's not an alien mothership, it's not deploying probes, it's just a comet. But just a comet doesn't do it justice. This is a messenger from another world, a time capsule from another era, a traveler that has journeyed for millions or billions of years across the vast emptiness of space to briefly visit our solar neighborhood. That's extraordinary in its own right. The debate around 3I Atlas reminds us that science is a process, not a destination. It's about asking questions, gathering evidence, testing hypotheses, and adjusting our understanding based on what we learn. Sometimes the wild hypotheses turn out to be correct. More often, they don't. But the process of testing them advances our knowledge either way. As 3I Atlas continues its journey out of our solar system back into the darkness between stars, it leaves us with more questions than answers. What other interstellar visitors will we discover in the years to come? Will any of them show genuine signs of artificial origin? And how will we know if we're looking at something truly alien versus just something we don't yet understand? One thing is certain, we're living in an incredible time for astronomy and the search for life beyond Earth. The next decade will bring discoveries we can't even imagine. And when the next interstellar visitor arrives, we'll be ready with better telescopes, better instruments, and better questions. Until then, keep looking up, keep questioning, keep seeking the truth. Because out there, among the stars, are mysteries waiting to be solved. This is She Speaks Anyways, reminding you that the universe is stranger, more beautiful, and more wondrous than we ever imagined. Thanks for watching, and I'll see you in the next video.